Today, we are going to discuss the relationship between climate change mitigation and energy. This is very important because the world economy needs a quick and deep transition away from fossil fuels and the expansion of renewable energy. Today, we are going to discuss how feasible is from the technological perspective, from the economic perspective, and from the political perspective, this transition. We will begin by analyzing the evolution of carbon dioxide emissions coming from fossil fuels mostly in the last 20 years. But before going to the data, it is important to concentrate in a particular group of conclusions. The first finding is that between 2007 and 2020, in the last 13 years, carbon dioxide emissions from developed societies, excluding Russia, declined by about 25% in developed countries, declined by about 25%. So a deep technological change is already going on in developed societies, which are the leading in technological change. Secondly, this decline actually is a result of different factors, including the last decline produced by the pandemic. Nevertheless, the most important factor was a dramatic expansion in the growth of renewable energy. So why global carbon dioxide emissions continue growing? Well, this is mostly the effect of a huge expansion of emissions coming from China. But China is not the only country where emissions are growing very quickly. We have also India and also a group of emerging economies coming from basically Southeast Asia. If we analyze the global emissions, we also might think that emissions have already peaked, reached a maximum, or are going to do so, and they might continue declining in the short future. Here we are moving to the data coming from British Petroleum, and we are representing here the evolution of carbon dioxide emissions from fossil fuels since 1965 to the year 2000. In blue, we have the emissions of the world emissions. And it's interesting to see that they are continuing expanding, but in the last maybe 10 years or so, they seems to have reached a plateau, and maybe they can continue declining in the future. But if we concentrated in the yellow, in the orange line, which represents emissions from all developed countries, excluding Russia, we see very clearly a decline that began around 2007 and is continued. It has been steady and was sharply increased with the expansion of COVID in 2020. So there is a strong decline in change in emissions, in total emissions coming from developed societies. Nevertheless, world emissions didn't decline as well, mostly as a result of the expansion of China, India, which are depicted in red, and other emerging economies that are depicted in yellow. Actually, the expansion of China is slowing down. That is important. And the growth of China actually is not as fast as it used to be before 2014. Here we analyze the installed capacity in renewable energy sources at the worldwide level by source. In the blue color, we have different kinds of hydropower. Hydropower is expanding, but slowly. But the great change, the most important change that has been very intense in the last years is a huge expansion of wind energy, which is depicted in brown, and photovoltaic solar energy, which is depicted in yellow. So both together are changing actually very quickly the structure of energy generation worldwide. If we take the whole analysis, we can see that actually renewable energy sources actually have grown by more than 3 times in the last 20 years. That is an impressive expansion, but if we concentrate only on wind, represented in blue, no, represented in orange, and solar, photovoltaic solar, represented in blue, we can see actually a dramatic change, because at the beginning of the century, actually, these energy sources were absolutely marginal, and now they are really significant at the worldwide level. The expansion takes place at around 20% per year, which is a very, very high growth rate. This expansion has been mostly the result of declined unitary prices. Here we have the time series of unitary costs of both solar and wind energy with different methods of calculation. But in all the cases, we have a strong decline. That means that per unit of energy, both solar and wind energy are becoming cheaper and cheaper. Actually, they are the cheapest way to produce energy. That is one of the main explanations about the speed in which we are now experiencing this expansion of the renewable energy sources. But the change is not only going on the sources of energy. Actually, there is another transformation that also was very important in the last years, and it's accelerating, which is the change in transportation, mostly land transportation. Actually, internal combustion engines based on oil or oil derivatives are being quickly replaced by both hybrid and electric cars. Here we have two charts representing. The first one in the left side is the evolution of sales of both hybrid and electric cars. Actually, in the last years of the chart, 2019, they continue growing in spite of the COVID crisis, and they reached more than 2 million cars sold worldwide per year. And in the next chart in the right side is showing a forecast up to 2030 of car sales, annual car sales by technology. And here we see two very important conclusions. First, internal combustion vehicles sales actually already peaked around 2017, and they are declining worldwide. They will continue declining very quickly, and the expansion of mostly electric but also hybrid car sales is quite impressive. They are expected to reach 25% of global car sales in 2030. And the process obviously will continue in the future. So this change is going to produce a dramatic drop in oil demands in the future. Here we have some projections made by British Petroleum about the evolution of oil demand in the next 30 years. They are according with 3 different scenarios, but in all the cases, there's a very, very sharp decline. But the change in energy generation is huge. Here we have the structure, the current structure 2020 of global energy consumption by source. If we take together oil, 33%, coal, 27%, and gas, 24%, we add up to 84%. And all renewables taken together, including nuclear also, are about a little bit more than 15%. And if we concentrated in wind and solar, they now represent only about 33% of energy, worldwide energy generation. So the technological change that it is required in the next 20 or 30 years is to reduce the share of fossil fuels from the current 84% to maybe 10 or 15% to fulfill the goals of the Paris Agreement. That implies a huge change. And the big question, the most important question is it feasible? Whether or not it is feasible. A good news is that most of the largest and more polluting countries in the world have already committed themselves to net zero emission targets. That means that they will become carbon neutral, mostly around 2050, in the case of China, 2060. If they fulfill these commitments, actually, deep change might be starting. 16 countries already have a law committing themselves to the path of net zero emissions. Those include Germany and Sweden, with 2045 as the target year. The European Union as a whole, Japan, United Kingdom, and South Korea. All are committed to 2050. In addition to this group, 31 countries already signed a political document with the same goal, including the US, Australia, Costa Rica, in Latin America, Ecuador, Chile, Uruguay, all of them for the year 2050, and China a little bit later in 2060. But net zero commitments not only include countries, they include also regions, cities, and companies. Together, they account for about 77% of global carbon dioxide emissions. That is an important recent change that provide us some hope about the possibility of fulfilling Paris Agreement goals. Here we have a chart that illustrates us about the change in getting away from fossil fuels that it is required in order to fulfill Paris Agreement goals at the end of the century. We can concentrate in the case of oil, which is represented in light blue. As we can see here, the transformation must be very quickly. Today, as we see already, oil is about a third of total energy generation, and in 2050, the oil consumption almost will disappear. The same is happening with all fossil fuels. So the transformation is very deep and quick. That's the required change in order to keep warming below 1.5 centigrade degrees at the end of the century. So, taking everything into account, we can formulate some very important conclusions. The first of them is that a quick and deep reduction in fossil fuels consumption is required to avoid catastrophic effects of climate change. This change must take place mostly in the last 20 or 30 years before 2050. And in 2050, most of the world needs to become carbon neutral. That's the first point. The second point is that the decarbonization path has 4 basic elements, which are the most important ones. First, expanding solar and wind energy. They are not the only ones to be expanded, but they are the most promising ones from the technological and economic perspective. Secondly, eliminating deforestation, which contributes to at least 11% or maybe 13% of global emissions of carbon dioxide. Third, reducing methane emissions from agriculture. If we reach these 4 goals, decarbonization of the global economy might be successful in the future. The most important point is that both from the technological perspective and from the economic feasibility, the decarbonization is feasible. That means essentially that we have the technology and the economic capacity to do so. So why we are not reaching this point, why there is a huge gap between national commitments and Paris goal? Essentially for the lack of political will. That is the most important obstacle for climate change mitigation and for sustainability as a whole, taking into account also biodiversity conservation. And this political will, this lack of political will, obviously, is the result of the structure of political power in the decision making and the influence of very large corporations linked with fossil fuels. So that is why the transition away from fossil fuels remains still uncertain. It is important to remember that in order to fulfill the Paris Agreement, this transition is required, but if we fail to do so, the risk of unleashing tipping points leading to a non-reversible hot house Earth scenario remains very high. It is not going to take place immediately. It is not going to take place in this century, but in a scenario going to maybe 200 or 300 years in the future, this change is still very risky. So it is important to take now the appropriate decisions and to implement right now in the next maybe 10 or 20 years the required change to save the planet. Finally, as a broad conclusion, it is important to point out that a sustainable future for the planet requires not only effective climate change mitigation, but also biodiversity conservation. And third, very important, social distribution. We need to move towards a future world that will be at the same time equitable and sustainable. These three goals taken together must be achieved in a way in which all of them are trying to reinforce each other, as the Sustainable Development Goals from the United Nations have already established. So the transformation that it requires for the world economy and society is very deep and actually implies a very, very deep social change and the construction of a new society and a new set of values worldwide in the future. Thank you very much.